Speaking about the different power density, this is a graphic I designed some months ago for a publication we did in Germany. It compares. We take this is to show that the electricity from energy plantations is an inefficient manner to use solar energy. Here we compare two manners to supply one house with energy. We suppose that this house needs per year 3,000 kilowatt hour electrical energy and 6,000 kilowatt hour thermal energy. These are common values for a German one-family house with certain characteristics. And now you can generate this electricity once from PV panels. Then you need about PV panels of 30 square meters to generate this energy you need. Or you make a plantation, in this case of maize, which is common in Germany, a common plant we use to generate energy. And then you need a field of about 2,500 square meters. This graphic represents the same. So here you need the solar radiation, or the solar radiation you need here for this possibility for the PV panel is about 30 megawatt hour per year. And when you take the bypass via bioenergy, then you need 2,500 megawatt hour solar radiation to power this house. Okay, so now we have here some technologies to transform the energy in the usable energy. That means electrical energy and thermal energy. So in this case, PV delivers electrical energy. The electrical energy is partially used directly as electrical energy, and the other part is used in a heat pump to generate the thermal energy the house needs. Or in this case, we harvest chemical energy, bioenergy, and this chemical energy is used in a combined heat and power generator to generate then the needed electricity and the needed heat. So this is an example just to compare the different power densities of the different energy resources. We have to take this into account also when we design an energy supply system, because land area is a very limited resource, especially here in such a densely populated country or densely populated island as it is Java. But in Germany we have the same situation. It's also quite densely populated, not as densely as Java, but also quite densely populated. Okay, so the land usage is a very important aspect when we speak about renewable energies. By the way, that's also a reason why energy efficiency is not only important now in order to reduce the consumption of fuels, but energy efficiency will also be important in the future, because the resources are always limited. Also, if we speak about renewable energies, the resources are limited. It's renewable, but the available amount is not illimited. It's limited. Huh? Okay. Just developing a bit more this topic. The situation is even a bit worse, because you can generate from an energy plantation like this one about 20 gigawatt hour per square kilometer and year. You get this as in the form of chemical energy, but you use fertile land with a high potential for food production, with a high biodiversity protection potential, and with a high carbon storage capacity. And compare this with a solar system, you generate 85 gigawatt hour per square kilometer and year. Electrical energy in this case, not chemical energy, but you can do it on poor land without food productivity potential, with a lower diversity protection potential, and practically without carbon storage capacity. Okay, so what we learn here is that bioenergy, I will say something about bioenergy now, because bioenergy will play an important role in the future energy supply system, but rather bioenergy from waste and less bioenergy from energy plantations. We should avoid energy plantations, and bioenergy should be used if there is waste available for energy usage. Okay, another important point, another important criterion in order to select the sources we want to use to power our energy system is what in the terminology is called the dispatchability of the electricity. This means, dispatchability means we can generate electricity on demand. Take a wind turbine. If there's wind, you generate electricity. If there's no wind, you don't generate electricity. That's a disadvantage of wind energy. Take a biomass plant. You can accumulate the biomass, and you can use it whenever you need it. This is an advantage of a biomass plant. Same hydropower. You have a storage, if there is one, but there may be one, a reservoir, water reservoir, so you can store energy here in form of the potential energy of the water, and you can use it whenever you need it. So you can generate power on demand. This is the role of bioenergy in the electricity sector, preferably from waste, not from plantations. You can store the biomass and you can use it whenever you need it. This is a clear advantage of bioenergy. Or there's an interesting discussion ongoing between in the solar energy sector, between people who defend photovoltaics and people who defend concentrating solar power. I myself, I worked for several years in projects about concentrating solar power. So 5 or 7 years ago, concentrating solar power was very interesting because it was cheaper than PV. Now it changed. PV is cheaper than CSP. And actually, many CSP projects are not realized now. Projects that were planned in the past. Because CSP is now much more expensive than PV. But there's an advantage of CSP over PV. Because in a concentrating solar power plant, it's easy to integrate a storage. And then you can generate power on demand. Because in a concentrating solar power plant, you generate first heat, and then you use the heat to generate electricity. To store heat is very easy and cheap. Much easier and cheaper than to store electricity. So this is an argument for the construction of CSP plants. Okay, so speaking about the electricity system, future systems in many countries, not in all countries, but in many countries, will rely on solar energy and on wind energy and on some other sources. There are other countries, Norway for instance, will always have 100% from hydropower. That's a privileged situation. That's a special situation. This will not be our situation in Germany. It will not be your situation here. Other countries, most countries in the world, they will use in the future solar energy and wind energy. But this means new challenges for the grid operation, because solar energy and wind energy, or the solar resource and the wind resource, are unstable sources. They are fluctuating. And it's not so easy to generate power on demand from them. So until now we had the situation that this is the traditional power supply system. We have a certain load, and our power plants, they follow the load, and then there are different power plants. Some of them they run always, like for instance coal power plants, lignite power plants in Germany especially, and hydropower plants. Then you have other power plants which follow a bit the regular fluctuations in the load, and then you have peak load power plants that are very flexible, and they can follow the load in a very flexible way, normally gas power plants nowadays. Also pumped hydro storages, which are also used for that. So this is the traditional situation. You have power plants, controllable power plants, that follow the given load in the grid. In the future, this will be a bit different. We will have high shares of solar energy, high shares of wind energy, and they are fluctuating. And they don't care about the load. They don't care about the load. They're just fluctuating according to the natural conditions. What does this mean? Somehow we have to adapt load and generation. They must always be together. So the future system must apply new strategies to match load and supply. For instance, load management will become more important. Load management means that, contrary to what is the case until now, that the generation follows the load, we should try to apply measures in order to make it possible that the load follows the generation. We can do this, for instance, applying variable prices. Sometimes electricity is cheap if there's a lot of wind. So people switch on their washing machine and so on. Or electricity is expensive because there is, for instance, no wind, or there is no sun during the night, whatever. Prices are high and people reduce their consumption. So load management in the future may be one very important instrument to match load and supply. We will need controllable power plants. So hydropower is interesting. Biomass power plants are interesting because we can deliver power on demand. And maybe in some countries this is not an option for Germany, neither for Indonesia, concentrating solar power plants. But in Northern Africa, for instance, this may be an option. They don't have hydropower, they don't have biomass. So where do they get their dispatchable electricity when they need power on demand? Where do they get it from? Yeah, maybe from CSP plants. Grid expansion may be important, especially if you have a system with a high share of wind energy. All scenarios for Germany predict that wind energy in the near future will be the most important source.